Welcome back. Today I'm going to bring you up to speed on the custom air ride bike build. The goal here is to communicate what I've done so far in the event you want to try to recreate it if you so choose. Then in the future, as I'm working on this bike, I'll make sure you get brought along for the ride. There's a lot here, and I did put timestamps in the description to help you navigate. One of the most time-consuming things with a scratch build is finding the required parts to make it all work. And I'm going to show you what parts I use throughout this video. If you have any questions, please leave me a comment or send me an email at heritagerestoworks@gmail.com. Carrying on our heritage is not only about remembering the past, it's also about carrying forward that tradition of ingenuity and perseverance and challenging ourselves to try something new. This project has been an opportunity for me to expand my skills and knowledge with the air ride system and continue to improve things like my metal fabrication skills. My name is Matt. If you haven't done so, check out my intro video. It explains who I am and why I'm here. And please, click that like, subscribe, and share button for me. Help me get others engaged and out in their shop. Let's jump in. Before I could start building anything, I needed a few components. And anytime you're building from scratch, there are a few things you need before you can even start building the frame. The engine, the wheels and tires, and the air ride, the main air ride components. Let's start with the engine. In the spirit of the channel and what I do out here, I did look at 3 engines to rebuild and restore for this project. However, I wasn't sure if the air ride system was going to work, and as mentioned before, I wanted to spend my time on this side build more with learning better metal fabrication and learning the air ride system. So that was more of the goal with this build. As I mentioned in my intro, I don't have unlimited time. Occasionally have to make decisions on what I rebuild and what I buy. And in this case, it's a side project I've been working on for about a year. I'm rebuilding and doing other things typically anyway. So it's been a great project, but the engine, I did decide to purchase it. It is a 250cc, as I mentioned. It's 4-speed and has reverse, so that might get interesting when I get it running and drivable. I do have a gear indicator wired up front, which we'll look at in the future and be able to see that, but it shouldn't be too bad. I did want an engine with a transmission this time for sure. When I built the trike, I used a 460cc Predator, and it's a lot of fun. It'll run 50, just a little bit over the way I have it geared. But I did want a transmission, so that was a main goal with the engine and part of why I bought this. I don't have it running yet, so where we'll pick up after this video is really with the wiring and air ride system. So I don't know yet if it was a good purchase or not, but stay tuned and we'll see. Next, the wheels and tires. And I needed this up front mainly because you need to know how wide your frame, forks, and A-arm, if you're using an A-arm component, needs to be. And I wanted a fat tire bike here. And the wheels I used, these are from OMB. It's an 8-inch steel ATV wheel that's 5 3/8 inch wide. It's a 4-inch circle bolt hole, and that's important. I used this wheel hub from BMI Carts, the 1-inch bore, and the back wheel, notable, it's a through axle setup with a 1-inch axle. On the front, I use this 8-inch mini bike drive wheel from Go Power Sports. It's actually a back wheel, It has the 4-bolt connection on both sides of the rim. It would be typically used one side for a sprocket hub, the other side for a brake hub. In my case, I wanted to run dual calipers up front, so I ended up getting this back wheel to actually use up front. And it does have an 1/8 inch center bore, and we'll get to that later. For the tires, I wanted a fat tire that was knobby on this build. On my trike, I used Hoosier tires, more of a road tire, or dirt track tire, I should say. But I wanted a knobby, big, meaty build on this one. I ended up going with these Carlisle, I think that's how you pronounce it, but they are 22 by 12 by 8 ATV tire, and they're a pretty big tire. You don't have to use this tire. You can use any tire. The main figure in these numbers is that 8 at the end. You need to make sure that your tire is 8 inches, the opening, so it'll fit on the rims that I just showed you. But the size, type of tire is really up to you. It really matters that it's 8 inch here. But I like the look. I think it's coming together well. While we're talking about the wheels and tires, I also wanted to just quickly run you through the full axle build out, and that way you have the components that I used there. This isn't something that you actually need up front, but the first thing for the back wheel, a 1-inch keyed axle, and I got this from McMaster Car. I got the 18-inch, and I did have to cut it down slightly. I didn't want a lot of overhang there. I also got this live axle kit from OMB. It's the standard live axle bearing kit with 3-hole flangets. You can get these from any company, anywhere. I also got this sprocket hub from, I believe, OMB. It's the billeted aluminum sprocket hub, and it's for a 1-inch axle, which of course all of these will be in, is important. I got this sprocket from Speedway Motors, and you'll see what's important there is the 530 in the name. This is a 530 sprocket, and it fits a 530 chain. This engine, the sprocket that comes off the transmission, is a 530 sprocket. Unless you have a way or a different size sprocket, you have to use a 530 chain. I am using a Jackshaft in this build. I could have adjusted the chain size on my secondary run to the back tire, but I like the 530 chain. It's a really beefy chain, and I wanted to stay consistent with that final run. On that 530 chain, it's easy to match up that back sprocket, which also had 530, it's a 530 chain. Where it got a lot more complicated was at the Jackshaft. The only 530 sprockets that I could find for a 5/8 or even 1-inch bore I was looking for were Harley-Davidson replacement sprockets for the transmission that were spined. They had a spindle insert. And I looked and looked, and what I finally came to understand was the differences in motorcycle and the ANSI standard rating of chains and sprockets. And that's very important. We'll talk about that a little more, and I am gonna make a separate video, a short one, just to explain that, because I can't even describe how many hours I spent digging into that, trying to determine what motorcycle chains work with what standard rating sprockets. So very important. In short, in a nutshell, the number 50 sprocket will work with a 530 chain. The number 50 sprocket will not work with a 520 chain or 525 chain or 540 chain, only the 530. So that's very important with this build. I also, for the back wheel assembly, got a brake rotor hub. This is from OMB as well, just a standard rotor hub for 1-inch axles. And then I did get a brake rotor, the 7 1/8 inch by 3/16. When you're buying your brake rotor, you want to make sure that the hole pattern matches up with your brake hub. Same thing for your sprocket. You want to make sure that it matches up with your sprocket hub. The last thing to finish up the back axle assembly are the lock collars. And I just bought 4 lock collars, 1 inch. You can get those about anywhere. Just to finish up the front wheel axle components here, I did get a 5/8 inch chromoly rod, which I cut down and then tapped the ends. I did that later in the process, but wanted you guys to be aware up front of what that is. You can typically buy these axles pre-threaded at specific lengths, McMaster-Carr, OMB, BMI, a lot of other places. With this specific build, since it's custom, I had a custom width on those front forks. That's why I ended up using the 5/8 inch chromoly rod. I couldn't find a 5/8 inch axle that fit the dimension I needed without a lot of overhang. The next thing I needed was to determine what shocks and bags or a combination of both I was going to use. And long story short, I ended up going with these Monroe Max Air shocks. They have a 5-inch usable stroke, which was a little more than I saw on the motorcycle specific air shocks that were made like this. And I wanted to get the most vertical travel that I could. You'll see that shock comes with that stupid air cap and that tiny line that comes in. I cut that off completely and ended up drilling it out and tapping it for a push to connect fitting. The push to connect fitting I used was made for 1/4 inch air tubing, and it's an 1/8 inch 27 MPT threads. The drill bit size on that is 21/64, which is an odd size, but the metal on that shock is so hard, you are going to need a good bit. So make sure you get a good bit to drill that out, and then make sure you get a high-speed fluted steel tap, 1/8 inch 27 MPT. I tried for 2 nights, struggled with trying to get that tapped with just a basic tap I had in a pack. And it was not working. I tried one night for 2 hours. My arm and shoulder hurt and everything else. And I ended up buying that high-speed fluted steel tap, and I had it done in 20 minutes. So get that high-speed fluted steel tap. That metal that's pressed into that shock there is very hard, so it'll save you some time and effort for sure. You'll see on these shocks, one of the ends also comes with that extra extension. I cut off that to make sure it would fit in my planned bracket. For the back, I ended up going with this Vixen Air. It's a 1/2 inch NPT single port bag. It does have a 9.5 inch usable stroke. If you remember, I mentioned the front is about a 5 inch usable stroke. And you'll see the reason I can get more travel than this is the shock is not the point of contact with the ground. If you think about the back here, where the airbag is and where this is actually contacting the ground, it's a lever. It's much further back than where the shock is. So the range of travel is actually a lot more. And that's why I can get more, a little more than the 9.5, about 11.5 inches of travel frame off the ground. The front, again, it was 5 inches. It still has that pivot point. Because of that front bracket, it pushes that axle out a little bit front ways, and it has a much larger circumference and range of motion. Okay, that's it for the upfront items. Let's move on and actually get into the building. Really, any build starts with the neck. And you can see here, I did use a neck cup kit. You can Google Harley neck cup kit. Effectively, I got mine from Lowbrow, I believe it was. You also have to get a 1-inch neck bolt. And I got mine from TC Bros. And then that doesn't come with a nut, so you also have to get a nut for that. And I got mine from Dennis Kirk. It took me a while, like I mentioned, to find all these parts. I didn't necessarily see one on TC Bros and vice versa. The neck bolt, it doesn't actually say the thread size in the description, so I kind of took a chance with the Dennis Kirk item, but it did end up working out. What you want to do is mic the part of the cup that gets inserted into the pipe. And you need to find a piece of pipe that the inside diameter matches that, preferably a little bit smaller. Then you can take your Dremel and hollow out a little bit as needed for a nice tight fit. You don't want a loose fit in there. You want a nice tight fit when you assemble the full neck. To establish your neck length, that pipe length, you need to take your neck bolt minus the bearing cup times 2, minus the triple tree thickness times 2, minus the nut thickness, and you have to leave a little room for overthread and paint. Once you get your neck cut down, use a Dremel, like I mentioned, and a sanding disc. You can hook your shop vac on the other end. I'd probably take the bag out of it. I usually just put a little water in the bottom of mine and hook it on the other end. That way all of the dust gets sucked through the shop vac and helps keep things clear around here. I try to do that when I can. Typically at this point, you would put the neck on the frame jig and mock up the engine to get your neck height and then start building the main frame. I knew I wanted 27 degrees of rake, more like a sport bike than a chopper. However, with the shocks and movable front axle, I didn't know if 27 degrees of rake would get me the appropriate amount of trail. So I had to start with building the front forks before I locked down the neck position. If the trail was bad, I could increase the rake to increase the trail. I considered talking you through rake and trail at this point, but I think it's an important enough topic that I'm gonna make a separate video to release with this one. So let's talk front forks. I used 1-inch 4130 chromoly. It's 0.95 wall, and I ended up getting 2 4-foot sticks. The typical wall thickness is 0.83, 0.95, and not chromoly, so I do way overkill and get a lot bigger than I need. I don't build a lot out here, and just keep that in mind if you're buying materials. You can use DOM 083, 091, or other things of that will work just fine. And to build the front forks, I used the opposing side of that 5/8 inch piece of MDF to lay it all out, clamp and tack it. I knew how wide I wanted the forks by the steering neck, and I knew how wide I needed the forks down by the tire to clear all of the components. So I laid all that out on the back side of the board with a marker. And I'm going to show you that real quick on a piece of cardstock. Okay, I wanted to take you through quick how I use the MDF board, and that's a 5/8 inch thick piece of MDF plywood. And what we're going to do on this smaller scale is pretend that this white piece of paper is our piece of plywood. The first thing you want to do is make sure that you find a square corner. Use your big square and make sure you have a square corner. Then what I would do is measure in about 4 inches from the side off that square corner. I would come in and I would make a pencil line on those lower marks and a pencil line on those top marks. Then I would bring my square back in and I would set it in those pencil marks and make sure that my starting point and my corner was all square. You're going to end up measuring only off of these 2 lines. Once you have confirmed those on the board, what I would do is really come in and darken those lines up. And the reason you want to do that is you're always going to measure off of one of these 2 lines because you know that's your square corner. And if you're always measuring off one of these 2 lines, then you know that whatever you're building out is also going to be square. So now that you have that, I knew that I wanted about 6 inches between my fork tubes at the triple tree. I also knew I wanted 17.5 inches between my tubes down at the front tire to clear everything. So what I did was I grabbed that 17.5 and I put that on my board to make sure my starting point as I worked from the top of the forks to the bottom wouldn't put me off the board. So what I did was I just kind of found the middle spot here, and I marked that. And again, I knew I needed about 6 inches between my fork tubes. So what I came down here and did was I measured off this line, and I came up to a reasonable spot where I knew I would have enough room. And I just put a mark there, and then I knew I needed 6 inches more than that to get between my forks, and I'm going to scale it down for this demonstration. But let's say that that is right here. Always measuring, I just added the 6 inches on. So now what I have to do is, I have my distance for both of those marks. I'm going to come down my board, and I'm going to put that same distance on both of these sides. And then I'm going to come in and I'm going to connect these lines. And this is effectively going to be the inside of our fork tube. All right, so the next thing we're going to do is actually finish off the tube so that we have a way to judge when we're laying out things, both sides of that tubing. So we know that we came to whatever this distance was and added 6 inches to get to our central space that we need. We need to add an inch, and down here we need to subtract an inch. So we're still always measuring from this bottom line, and whatever that measurement was, we need to add an inch to that, and then we need to subtract an inch down here. And we're going to do the same thing down at this end to create. We need to subtract an inch from that one and add an inch there. And then we're going to go ahead and connect these lines up. And that's going to give us the position of our two fork tubes at the spot of the neck. Now, we know that we need a much wider bend or much wider space down at the tire. So we knew that we needed 17, a little over 17 inches to clear the tire, the shocks, all of that. So what we'll do here then is we made sure to measure off, and what we'll do is we're going to take half of that distance and we're going to put a mark so that we have our center. And then what we're going to do is half and half that 17-ish inches that we need and measure off that point to get this side and the inside of our other. Yep, that was right. So that's going to be the inside distance that we need for our outside to clear our tire. And we're just going to come up here and we're going to go ahead and put those measurements again. Two, there's our 8. And we're going to go ahead and connect these lines. And this will effectively become the inside of our wider portion of our fork. Right? And we're going to do the same thing we did to create these fork tubes. We're going to measure off this, whatever that distance was. We're going to subtract 1, and then we're going to measure off this, whatever that distance is, add 1. Same thing down here. Subtract 1. And add 1, we're scaling it back. And then connect up those lines. And here. And then we have our outside fork tubes, and we're going to go ahead and label those so we don't get confused. Now, the second thing we know is how wide our neck and triple tree is. So we're going to go ahead and measure that off this line. And let's just say, for example, we're coming down about 7 inches, and we'll scale that back here. So we'll do, and we're gonna mark where our triple tree is. And you can go ahead and box those in when you're laying out later. You can use that as a point of reference to make sure everything's square and looking good. So those are gonna be our 2 triple trees. And we know that we want our bend to start about 1 inch below that triple tree. So we're gonna go ahead and measure that, and we're gonna put a mark here on our board where we want that bend to start. We're gonna measure off that line, we're gonna take that, and we're gonna transfer this measurement down here. We can connect this up, we can take this measurement on down to make sure our line, you feel free to use different colors so that you remember and understand what your different lines are and should be. So that's gonna be where our bend starts. And part of the reason I wanted to show this example is your bender, the die in your bender has a radius. And for most benders, and different benders are different the way they're set up, but for most, you can't bend a 45 and then immediately make another 45 bend. Because of that center line radius and because of how the bender's set up, you make your first bend, if you're gonna flip it around, you have to come down X amount of length before you can lock it in the bender again. And what happens is you wind up with a bend that is too long for the bend that you need. So what you can do there, and what I like to do is my bend, I marked where it starts. And what I'm gonna do is with my marker, lay my pipe on that piece of board, and I'm gonna mark this side, and I'm gonna mark this side of it. See that? Let's use a little bigger marker for this. So I'm gonna line everything up. This wire is much skinnier than my pipe, but my bends aren't perfect here. Not the point. I'm gonna go ahead and line this up, and I'm gonna mark this tubing. Then I'm gonna bring my piece of tubing up until it lines up here. And I'm gonna mark this bend. And typically it's gonna fit with the width of your lines here. To get the section that you need to actually take out, what you're gonna do is use your square, and you're gonna come in here and you're gonna get perpendicular somewhere in the center of those marks you made. And you're gonna make a line on both sides. Then you're gonna come back in here and you're gonna lay your pipe back in, the top piece first, and you're gonna put a mark on your pipe on both sides and make that connection. Then you're gonna move it back up here. Bends aren't quite 45 there. And you're gonna do that same mark. And that's gonna tell you what piece of that pipe you need to cut out. Once you cut that out, then it will all connect up. You can clean that up, bevel your edges, and get a really good weld connection there. And that's how, with any kind of bender, any kind of die radius, you can change your bend if you're doing 45s. And I didn't want to do a fast bend and another fast bend, and even if I did, I couldn't. So just depending on your bender, you can get a little tighter with different styles of bender. But that's how I use these lines. And then what happens is, I come back in here and I'll router out different clamp holes based on where my lines are so that I can clamp everything properly. It also provides a point of reference, so when I bring that back in, I set it right back where it came off. I match up the triple trees. I match up these up here, and then I match up my pipes down here, my forks rather, and then I lock it all down. And I know I'm back to square, and that's how it's a jig, and that's how you can bring it back and forth from your frame jig and back, test things, make sure it fits. And I know the MDF isn't perfect. It's not a fixture table, but it allows you a point of reference. It does give you something to clamp to and hold things in pretty good position while you're doing this type of stuff. So definitely a recommendation, especially if you're on a budget. Next up were the triple trees. And I did use a 1/4-inch chromoly plate. For mild steel, I would maybe use 3/8 or 1/2 inch. I drew a template out for the triple tree on a piece of cardstock. And I want to show you how I do that quick. Let's take a look. All right, wanted to spend a quick minute with you on how to draft up a triple tree. And this is one that I made for the Springer fork build. I used this bottom section for the top and bottom tree, and then I used the bottom plus the top section for the middle triple tree. The one I made for this bike, I did in FreeCAD, a little more simple. There's no Springer forks. It's just a standard tree. You definitely don't have to use the computer. You can draft it out. And I'm gonna show you how to do that real quick. Always start with a square corner, just like we did on the MDF. And the first thing I'm gonna do is I'm gonna make a reference line, a center reference line. And my paper here is about 12 inches. So I'm just gonna make a mark at 6. I'm gonna come up my paper some, make another mark at 6, and I'm just going to connect those up. And that'll be our center reference line to work off of. And I always like to start with the stem neck. And in this build, our stem neck was 1 inch. So we know that we're going to need a 1-inch hole in our triple tree to accept the stem neck. But I did mic the nut that goes on the stem neck, and it's 1.7 inches. And I do have a circle here that's 1.5 inches. And what we can do is just kind of cheat it. And we're going to mark it because we want to make sure that our nut isn't overhanging our triple tree. And again, our nut is 1.7, just a little under 1.75 inches. This is 1.5 inch circle. So we're just going to make a little reference circle here, and we're going to cheat it up just a little bit so that we make sure that we have plenty of room for our triple tree. And again, we know that our stem neck bolt is 1 inch. So I'm just going to come in here and eyeball it and get the center that we need. And what I'll do for this, since it's a drill hole, I'm going to make it a different color. All right, and that's where our stem neck bolt's going to come up through the triple tree, and I'm going to go ahead and mark it 1 inch because we know we're going to have to drill that hole 1 inch. And we know we're going to have clearance for our nut. Okay, so on our triple tree forks, where our forks come through, you can see that typically between where the stem nut center is coming in and where the fork center tubes are coming in, there's an offset. They're typically offset forwards. I think on the Springer forks I did 1 inch. I did a little less on this air ride fork, and that's because of the trail. I wanted to try to get as much trail as I could with the setup that I had. So what I did, ended up doing about 3/8 of an inch, a little bit under 0.32 inches is where my offset is for my front forks. So I'm gonna go ahead and mark that. I do need to find the center of my circle here, and this will come in handy later. So I'm gonna use my hash marks there and just mark that center real quick. Should have done that a minute ago. And that'll tell us right there is where we'll put our drill. Okay, and that's what we want to measure off of. And about 0.32 is what I used, about 3/8 of an inch. That's about the top of this stem neck bolt that's coming through. So what I'm going to do is measure that off this bottom line, and that's about 1.5 inches. So what I'm going to do is I'm going to make one more reference line. I'm going to come over here. I'm going to mark 1.5 inches, and then I'll come over here and mark 1.5 inches. And I'm going to draw this in and use it as a reference line because that's where the center of my fork tubes are going to be coming through. And you can see just a little bit of an offset. If you're doing a standard fork, you can use 1 inch, 2 inches, or anywhere in between to do that. Now, what we know with this build is I needed 7 inches between my fork tubes. On the MDF test that we did, if you remember, the example I gave was 6 inches, but on this one we did 7. So what I need to do, and what I want to do on my reference line, is I want to split 7 in half, and I want to go 3.5 inches each way. So I want to go 3.5, mark that. I want to come back 3.5 and mark that. And that gives us 7 inches between our forks. And we know that our tubing fork is 1 inch. So I want to set that, and I want the edge of my circle, the inside edge, on my mark. Because remember, we want 7 between the tubes. So I'm going to set that on my inside mark, inside of the circle, and mark it. And these are actually going to be drill holes. So let's go ahead and mark those in with a different color. And let's also go ahead and mark these center lines real quick. Fill those in. Perfect. And that's going to be, of course, where we put our drill. And we'll go ahead and label these. We know these are 1 inch, pretty easy with this build. It's not always like that. And you can see our triple tree starting to come together. The other thing that we need is we need handlebar risers. You can do this a couple different ways. If these were a little skinnier and closer together, you could put a plug in the tubes and drill and tap those. You could put your handlebar risers in there. What we're gonna do is we're gonna put the handlebar risers in this general area. And I do know that the handlebar riser base is 1 inch, and I need to make sure that I have clearance between the nut and those handlebar risers. So what I'm gonna do is come out, and I'm just gonna put my circle kind of on the edge, and I'm just gonna put a little mark in here, and I'm gonna measure it off of this center line. Because what I'm gonna do is I'm gonna get a standard distance, one that makes sure that has clearance on our nut. And I'm gonna do 1 3/4 inches, and that's pretty much where our mark was. Then I'm gonna come the other way and do the same thing. And then I'm gonna measure the distance off of my bottom line. Right there, it's a 1/2 inch and a 1/2 inch. So I'm in pretty good shape. I'll go ahead and connect these up just as another reference line for us to use. And the hole I need to drill here is 5/16. So I'm gonna go ahead and use my 5/16 template. I'm gonna mark it blue since it's a drill hole. Same thing with this, 5/16. And then I am gonna go ahead and mark that inch base just to make sure everything still looks good and when we fill in this template. And now we just need to start drawing in the triple tree and kind of making our design. And really your options at this point are pretty open. You need to not come back this way too much because as you turn the handlebars, you need to have tank clearance. But on the sides up front, it's really quite open what you want to do. And what I'll do is just use some of my other larger templates. We know that we need some space when we drill out those fork holes. We need some room around the lip there. So I'll kind of draw some of those in. We know that our handlebars, we're gonna have just a little bit of a bend here. And we know that we need to clear the base of our handlebar riser. So I'll kind of just hit that and connect that line up right below. Right, so now it's starting to come together. It looks pretty good. Probably didn't need that middle line, but we'll go ahead and just take the back off like that. And then we just really need to connect up the top one. What I'll do here is measure off where I want and need to make sure that I have clearance on that nut. And we'll do 2 inches, we'll do 2 1/4. Make sure we get good clearance and put a mark there. And we'll go ahead and make a reference line. So 2 1/4 and 2 1/4. Let's go ahead and connect those up. All right, perfect. And you can see the triple tree start coming together. Now, you can use other templates. What you want to do up front's kind of up to you. Maybe you want to drop this in. I could use maybe that as a reference point, kind of these two in this hole. You know, maybe you wanted to do something like that. You can really design it however you want. There's not a lot of limits here on what you need to do. And you could, you know, make these a little nicer. Maybe that comes down and that comes down. Maybe you got a little more of a rounded edge here. You could put your wheel back up and make it. But there you go. There's really the triple tree is coming together. Once you have your cardstock template, if you're using an angle grinder and cutoff wheel to cut your metal, put your cardstock template on your piece of metal and mark it with a paint marker. Cut it out with your angle grinder and then switch over to a flap disc and clean it up with your flap disc. If you do have a plasma cutter, you would take your cardstock, put it on the 1/4 inch piece of hardboard, and then use either your router or jigsaw to cut it out. Keep in mind that your plasma cutter, where it cuts, has a very tiny offset. Typically, it's about 1/8 of an inch. What I typically do on my final hardboard template is once I have it marked with the cardstock, I'll draw around it with a large tip Sharpie. And your eye does a pretty good job at judging 1/8 of an inch. And I just take my time and draw all the way around it. And then typically I do use my router and I'll route all around that mark, making sure to leave just a little bit. Then I'll put it in my vise and I'll use a wood file and just file and fine tune it down to where I want to be and where that mark starts going away. When you're filing on that hardboard, it tends to kind of break up a little bit in different places. I don't worry too much about that. It still has 2/3 or more of it that stays consistent and gives a good guide for the plasma cutting tip to cut the metal. Once you have your hardboard template, clamp it to your piece of metal and then get to work with your plasma cutter. There will be dross on it, so you'll have to use a flap disc and fine tune it and clean it up good. Once you have them cut out on your piece of metal and cleaned up, you want to weld them together because this is the only way that you can ensure all the holes are square and lined up. Drill the holes, get 3 to 5 good bits of varying sizes. I start with the smallest bit, then move up a couple sizes again, all the way up to whatever I'm drilling, maybe 7/8, an inch, maybe 5/8 at times for different things. Get yourself a few good bits and look around. I know Rock Mount is where I got my bits, and I've been using the same bits there for over 3 years, which I only drill so much, but I do drill chromoly. So they've been good bits. I use a lot of oil when I drill with them on the press. But yeah, get yourself some good bits and make sure you have them stepped at a few different sizes. Once you have all the holes drilled, cut them apart with your angle grinder, a little skinny cutoff wheel, and clean the areas up again, clean the triple trees up again, and then they're really ready to go. Then I moved back to the board. I slid the fork arms up through the triple trees. I inserted the neck assembly, tightened that slightly, made sure everything was square and level, clamped down, and then I tacked it. Made sure it was still all square, took it off there, took my board down, and on the table, full welded it. At this point, I was able to put the forks back on the frame jig to start testing my shock position. Plane of reference comes into play here, and because I want the bike quite a bit off the ground, I'm using the concrete floor as my plane of reference. This is important because I know that with my mounted front tire, the axle is going to be about 11.5 inches off the ground. I did have these upper tabs left over from something else. They're from Ballistic Fabrication. I put them on the shock and tested the clearance. I did have to grind out the front end some to make sure that the shocks had enough clearance for the movement. I had an idea of how I was going to build the lower brackets and where the axle would sit in reference to that lower shock mount. So I positioned where I thought 11.5 inches as close as possible from the ground. And then I marked that upper bracket with a mark on the fork tube. I brought the forks back to the board and laid it out back in line with all the lines I had set down earlier. I put a mark on the board where I had marked that fork tube where the bracket was sitting. And then I measured that and I marked the other side of the forks, same distance from the square line. I set the brackets, clamped everything down, got everything square, and then tack welded those upper brackets. I did tack them at this point, just in case I needed to cut them off and move them later if I was running into problems. At this point, I was ready to cut the fork tubes down. I set everything back on the board and clamped it down, and I marked the lower shock hanger spot at its most compressed position, and then again at its most extended position. I took half that distance between, and that's where I made my connection point on the fork. So I cut the forks down to the middle point that I had marked of those other 2 points and positions, and I actually cut it 1 inch back, because then what I did is I made 8 small metal strips and drilled 4 of them 1/2 inch so as to match the shock bolt size. Then I used a long piece of all thread to make sure everything was all lined up on the board, and I tacked the 2 outside and the 2 inside pieces. One thing I did make sure that the width of my box here was the same width as my shock hanger. Because of the bracket down there, I wanted to make sure that I had fairly tight clearances that still allowed some movement, but I didn't want a lot of play in that bracket. I then pulled it back to my main table and finished up the other sides and all of the final welding. At this point, I was ready to make the lower brackets. I used this design, and let's take a quick look at the measurements. I did want to show you this lower bracket really quick and give you the dimensions. Effectively, you saw the shape here. The layout that you see here, this front hole is the axle. This lower hole would be the connection to the shock, and this back hole here, a connection to the fork leg itself and that bracket. So looking at the dimensions between the center hole to center hole from the axle to that first 1/2 inch hole is about 2.2 inches. And then the distance between the connection to the shock, 3.1 inches. And then also when you have the axle here and that shock connection point there, it's on a 35-degree angle. If I had used a straight piece, it would have pushed that axle out too far forward, and I would have only had about 2 inches of trail, which is not enough. You really want about 3 inches of trail. With this shape, I was able to achieve about 3¼ inches of trail at full ride and about 2¾ inches of trail at full squat. In the middle, about 2 inches at half ride. The 2 inches is a little low, but still positive, and I don't expect to be riding the front that much at half squat. This does get a little more complex because the back is air ride and moves up and down, but all of the numbers I quoted you are with the back at full ride height, and anything else, the back being lower, actually increases the rake and trail the further it goes down. With the front shock fully extended and that back bag with all of the air out, the rake is closer to 35 degrees. So really, I'm in good shape at the highest ride height, and anything below that just increases those numbers and is still acceptable. It's very low or negative trail where you really run into more problems. Same as the triple trees, I did the cardstock layout that we looked at, transferred them to 1/4 inch hardboard, and then transferred them to metal. But I did do 2 hardboard templates because I did put them back on the frame jig to make sure that all of my measurements, the shocks, where my brackets were, everything was clear and I didn't have any problems. At that point, I clamped them to my metal, which I used a 1/4 inch chromoly again, same as the triple trees. Cut them all out, cleaned them up. There was, of course, quite a bit of dross, and just refined the shape and different things like that. I did weld them together, just like the triple trees, to drill the holes. It's the only way to make sure that the holes are straight. Once you have them welded together, you can put your paper template back on your bracket and then center punch each of the 3 holes. 2 connections, a 1/2 inch for the shock and frame connection, and then the end that gets connected to the axle, 5/8 to match the axle size. Same as the triple trees, cut them apart after you have them drilled and just give them a good clean, get them all cleaned up again. At this point, I moved the forks back to the frame jig and tested everything again. Everything looked good, and I ended up finishing out the lower bracket. To do that, I took a 5/8 inch inside diameter thick wall tubing that I cut down the same width as the shock hanger. I used a couple pieces of all thread to set the brackets equal width apart. I inserted a 5/8 inch rod to make sure each of the brackets and that center pipe were all centered, and then welded. I did tack it all around, made sure everything fit good, and then took it out and finish welded it. I did have to use the Dremel just slightly on the inside of those pipes from shrinkage due to the full weld, but really not much. I didn't have to take off much material. I did drill and tap that center pipe on each side for a Zerk grease fitting. I want to be able to try to keep down friction there. The other connections, those I currently have grade 8 bolts right now. But in the future, we will take those apart and put needle bearings in there and use shoulder bolts. So project in the future, something to come here. I also made the front axle at this point. As I mentioned earlier, I used a 5/8 inch piece of chromoly rod from Wix and just used a die on both sides. Took my time, used a lot of oil, and cut the threads in the depth I needed. At this point, I was pretty excited. I had finished that lower assembly for the most part. I could hook it up to my air compressor and see the action going up and down. And the next point was doing the front brakes. For the front brakes, I got 2 of these calipers. I made these brackets the same method as the triple tree and lower bracket. I put the forks in the most compressed position and then put tape on the rotor so the caliper fit real tight on that rotor. I slid an 1/8 inch piece of tubing up in the top opening of that caliper in the curve where the disc would be setting. I positioned it at the top of the rotor where I had plenty of clearance from the shock. At this point, I just slowly removed metal with a flap disc from the bottom of that bracket until I got the bracket mount holes to line up with the brake caliper mount holes. I then used spacers to connect the bracket to the brake caliper, and I had to do that because of the shock clearance and the fat tire. I then tacked the bracket, and I was very careful about using opposing tacks here and double checking my caliper alignment, and it was tight on that rotor from the tape and squeezed tight down with that upper tube in there. But with that, you have to worry about warpage and bending. So I was just very careful about tacking, opposing, and being very slow and not overheating my metal. Once I had it all tacked up, I took it all apart, brought it back over to the table, and effectively full welded everything. The forks are mostly done at this point, and mainly I've been able to confirm that the 27 degrees of rake gives me enough trail to make the bike track appropriately. This gave me the height that I needed to mount the neck on the frame jig. It also gave me the vertical travel that I would get on the front end. And what this allowed me to do was determine how high off the ground I needed to make the main frame to ensure that at full squat, it would be sitting on the ground. Now that I had the neck height that I needed and the height I needed for the main frame so that I could make sure it would sit on the ground, I could start the main build. It's very important when building from scratch that you use a frame jig. It keeps the neck and frame square with the axles, and it gives you a reference point to come back to that doesn't change. At this point, I placed the neck back on the jig and added the front forks to reset my neck height. I knew I was going to be 11.5 inches off the ground with my axle, so that put me where I needed to be. I mocked up the engine again, and then I did the drop arms. And I ended up doing a 70 degree on this first bend, and then 50 degrees on the second bend with a 5 degree offset. And keep in mind that front is tilted in to hit that neck up top. And that's why the second bend needs that about 5 degree offset. I had to make sure the main frame was long enough to house the onboard air compressor also. And I took all that into calculation when I was setting up how long I needed between the two bends. Once I had all that intact, next was the center ridge bar. I don't have a good pick of that, but in this one you can see the vertical square tubing. I locked that into position to hold up the back end of the pipe, and then I used a magnet to hold up the front while I tacked it. I left that vertical square tubing in place and built the drop arms. These were about a 30 degree bend to make the connection from the main crossbar to that lower bar. Once I had all those tacked up, I took it off my frame jig and put it back on my table, locked it down and full welded everything. That's the great thing about having a frame jig, because then it went back on the frame jig and I know and could test and see exactly that it was in the same spot. I then welded cross pieces in the front for more strength and as a place that I wanted to make the engine mount connections. I don't have good pictures of making the engine mounts, but similar to the other items, I used paper templates, transferred those onto metal strap, and then drilled and cut down as I needed to get good fitment. I attached each of those straps to the engine and mocked those up and then tacked on the frame once I had the good fitment. At that point, I pulled off the frame jig onto my table, again, full welded. Once that was done, I moved it back onto the frame jig, and that led us to the next step, the jackshaft. All right, let's talk the jackshaft. And as I mentioned earlier, these engines are typically made for an ATV, and that transmission sprocket would typically go directly back to the axle. So this is a two-wheeler, of course, and with that fat tire, I had to move the chain out with a Jackshaft. You can buy these Jackshaft kits anywhere. The key here are the sprockets, and this is where I ran into challenges. When I was looking for a 530 sprocket, the only thing I could find were Harley transmission type sprockets that had splined bores. I considered, sanding those out, but then I'd have to weld it, and finally was able to put down all of the sizes of the different motorcycle and standard chains and sprockets. And what I found was there's only two that are interchangeable between the two. You can use a 530 chain with a number 50 sprocket, and you can use a 425 chain with a number 40 sprocket. And that's because the pitch with those types of things are the same size between those, and they are interchangeable. What this did was allowed me to find standard sprockets, which there are a million companies out there you can buy from. And then I could get a 5/8 inch keyed bore. It's the availability out there for the standard size sprockets that matter here. All right, so once I had the Jackshaft, I positioned it, mocked it up with the Jackshaft axle and got it where I wanted it, tacked opposing tacks here and there to get it all locked down. Of course, took it all apart, back to the bench, full weld, then back on the jig. And at this point, we were ready for the rear A-arm. For the rear A-arm, I started with the connection to the frame, and I used a double Jackshaft setup here with a 5/8 inch chromoly rod. And I used the double Jackshaft setup because I wanted some extra strength and durability at this back connection. And those come with those internal bearings and things like that. That center tubing that I used is 3/4 inch inside diameter, thick wall chromoly tubing. And I used a 3/4 inch down to 5/8 bushing inside that pipe. I wanted to do something that could be changeable in the future as they wore, and I did add 2 Zerk grease fittings so I could keep it greased and help cut down on friction. I knew the width of the A-arm at this point to clear the back tire and the other components down there. And I moved back to the 5/8 inch MDF at this point to lay it all out. I did leave the legs long on the back A-arm so that I could cut them to length later. I also made the front connector pieces kind of curved and going in and tacked everything on the board. At this point, I aligned everything on the frame jig to make sure it was square to that center back post, so I knew that the back arm legs of my A-arm were square and everything was centered. At that point, I tacked it to that front pipe that I had made earlier that was 3/4 inch inside diameter. I then cut the legs off of the back A-arms to the correct length. I mocked up the bearing hangers I mentioned earlier in this video with that through axle through that back vertical pillar, and I tacked the bearing hangers all around using opposing tacks, making sure that the axle and bearings all stayed free in there as I went around and tacked. Doing this and using that frame jig really keeps that back axle square with the rest of the bike. At this point, I removed everything back to the main table, full welded everything, then returned it to the frame jig to test the airbag. I wanted the bag to be straight at full ride height, so had to angle the bottom mount a little bit. I closed in the A-arm connections at the front for extra support. I had to leave the center cut out so I could get to the airbag bolts on the bottom. And I cut the airbag mount plates at this point. Of course, the top and bottom mount, round mount plate for the bag, and then the angle side pieces that I need to get it straight at full ride height. Next, I created the upper mount by doing a 180 bend in the bender, welding that top bag mount plate to the bottom of that bend, and then making my cuts and fitment to the main frame and tacking there. At that point, I brought the bag back in, I bolted everything down, and really had a working roller at this point. The next thing on the list to take care of was the seat pan, and really bringing those arms back and making a spot where I could mount all of my air ride equipment and electronics. With the bike all the way in the squat position, I made the bars for the seat pan, and I needed to do it like that because I needed to make sure I had clearance over that back tire. I'm also planning a back fender to come up in there, so I had to create about a 1/2 inch of clearance there. I used the same tubing, and I did use 18 gauge sheet metal to make the base. At that point, we were getting a lot closer, starting to get to the point where I could work on the electronics and really start mounting some of the air ride components. A couple other things that I made on this bike were first the chain guard, and you can see here that I first made the curved top piece and then I made the outside piece. So 2 pieces I TIG welded together. I ended up dyeing it and filing it and picking it a few times. I'll have to do that again when I take the bike apart before final paint. I also made this battery box, and it's housed on the lower side of the A-frame. I did build those pieces so the battery size I was using would slide up and recess, and then I made a cover, again out of 18 gauge sheet metal, to cover that battery down there. I did include an LED battery indicator, and I used this pin plug. And I really like these pin plugs when there's any type of access issue. And this allows you to convert a charger, like I've done here, and plug it directly through and get your battery charged. You don't have to worry about dropping the cover and getting clamps in there to make your connections. Now, these pins are rated at 5 amps. I did buy some that said 10 amps, but I used my 10 amp battery charger on it, and it was heating up the plug after about 5 to 10 minutes. So I do think even if it says 10 amps, it's probably still 5 amps. You're still okay in most cases. Most car chargers are 5 amps and under. And what I have here is actually a 3 amp charger, and it'll run all day and night, and I don't have to worry about the plug getting hot. But for convenience, this is great, and I would encourage you to use this if you're doing a custom build. Another item that I did is the back brake, and you'll see I got this brake lever, and I ended up making a bracket for that, and then I also bought this brake master cylinder for the back brake. Same brake caliper as the front, and I do still need to connect those up. That's something that we'll do together in the future. We'll make sure we connect up the front and rear brakes. Next is the clutch and front brake lever, and I did get this clutch and lever. You'll see on the engine here there is a place to mount the clutch cable, and I did have to buy a little spring at the hardware store to provide a little backwards resistance and keep it closed, but pretty easy hookup. All right, getting pretty close on the build at this point. Next is really the electrical and air ride system, and this is where we're going to pick this build back up. In the next month or so, I'm going to do a video and mock up the air ride system on my bench for you. I'll also do a separate video and mock up the ATV wiring loom. So we'll do more there, and that's really where I want to pick up this build in the future. In the meantime, I will give you the details of what I'm using in this build. For electrical, I'm using this wiring harness, and it's a pretty standard wiring harness that will work for these engines. There is a wiring harness that has a little less light hookups on it and other components. It's a little more basic. We'll go through both of those on that future video before we jump back into this bike. I did make this front box here to house the key. It has a switch for the air compressor. It has a push button switch for future LED lighting that I'll put on the bike. And it has the air ride controls and gauge. Again, we'll talk more about the electrical portion of it. Really just wanted to communicate what I'm using at this point. For the air ride system, I needed an onboard air compressor. So you can Google air ride air compressor. There's a lot of companies out there that sell different models and sizes. Really for this build, I just bought the smallest size and least expensive compressor I could. And it's been working really great. I'm happy with it. I'm also using this dual air solenoid to control the air. And I like using this because it allows me to use these DC switches. I wanted to try that out. Plus, I didn't want to have to run air lines up to my little electrical box there and use analog switches. It just takes up too much room. Plus, I like using DC switches in other applications. I'm familiar with them. And that is something that I'm going to take you through in detail on my bench as part of this build in an upcoming video. I also needed the switch that's in the electric box because I needed a way to turn on and off the air compressor. And to do that, I also needed a relay. So you don't want the air compressor voltage running up through your little electric box. So you use a relay, and effectively that's just another switch that you're using the DC switch to tell to open and close. And we'll talk more about that when we talk the air ride system. You'll also see a PSI switch, and that's what tells the system to turn on and off. And you'll see on the switch it kicks on at 120 PSI and off at 150 PSI. I did use the glow shift air gauge, and this one is the one with external sensors. Again, I didn't want a bunch of 1/4-inch air lines running into my little electric box. So this glow shift dial comes with these external sensors that you put in line in the system. And then it has these DC wire sensors that run up to the gauge itself. And it makes the space requirement up in the main area compartment and panel a lot less. I also bought this aluminum tank. I did have to make brackets for it, as you see there, but it tends to work really well, and I'm happy with the air ride system that I have so far. Still a lot of work to do there. I'll end up cleaning up the lines, running those when I get a little further down the road, and we'll do that together. All right, let's talk a few other small items that I did on the bike so far. And one of those is the foot pegs you'll see here. I actually got these foot pegs online, and then I made a little bracket so that I would have a way to connect them to the main frame. Pretty easy to put on. I just, kept moving on and off of it to try to test, where is my seat position going to be and where is a good fitment for my foot within it all. Tacked those up as I needed, pulled the foot pedal back off, and full welded the outside and a little bit on the inside. The shift lever, it was too long and didn't feel right. It was too far forward for my foot, so I did shorten that up slightly. I did put a temporary gas tank on it. In the future, on this channel, one of the last things we'll do on this bike is make a gas tank. And I'm expecting to make kind of a fat, stubby, short one, but we'll see. As this all comes together, I get some of the other components on it. We'll see what looks best. I did put an exhaust on it. That's another small thing. I had to cut it down and turn it just slightly, make a few bends to clear the air compressor and some of those other things. I did back purge. I could do a little better job on some of that welding. But that's the main things. I did put a gear indicator up top here. When we go through the electrical system, we'll also go through that specifically. So I'm not going to spend a lot of time today with you. But yeah, I did put a set of handlebars on it, more temporary for now. I most likely will make a set in the future depending on what look we want to achieve. I mounted the air compressor, so you can see down there I welded a couple pieces of small tubing with a piece of strap welded on top of it so that I could mount the air compressor, one on each side. I'll end up putting gussets there and really everywhere around the bike before it's all said and done. Another thing I forgot to mention was the shocks that are in the back by that truck airbag. And when the bag is not full, it's a little bit jalopy, you know, it's pretty bouncy. When the bag's full, it's pretty rigid, and I can get about 140 pounds in the bag with this setup. And at that point, it's very rigid. But at the lower pounds, I didn't want it to be too bouncy, so I did come up and try these hydraulic shocks. And I'll find them here, what I got. I do think that they're 60 pounds each. I'll have to double check that when I pull down the picture of where I got them. But they do come with those plastic end caps that just suck. So I did have to buy these metal end caps, and they come with the male connector that I welded to the main frame. But those are just screw on. The plastic ones that come on it, it's threaded, and those plastic pieces just screw off. And then these metal ones screw back on. And they come with a little locking clip. So I'm hoping, and what I've tested so far, it seems to be working really well. I think the weights, and that's why I'll check the weights and maybe write them on the screen to make sure you have the ones that I got, because the weights are about perfect. Without any air, if I lift it, it almost wants to sink slowly, which is really what I was looking for. If I go too high on those shock weights, it's just going to want to jump off the ground. And if you go too low, it's not going to provide enough stabilization. So I think those weights really worked out well for this build. And there will still be some things we'll add to the bike. It'll get heavier, but that'll be fine. It won't be a problem. And I think those will work out really well. All right, that's a lot of what I've done so far. Really brought you up to speed with most things. At this point, let's talk next steps. First, if I started this channel a year or two ago, we'd probably be focusing here quite a bit to get this finished so that we could move on to other things. With that, and in the spirit of this channel, I'd like to do a few restoration projects and continue working on this on the side. Like mentioned earlier, I'm going to do specific videos and show you on the bench the air ride system and how to wire it and how it works. And I'll also show you that wiring loom. And that's really where we'll pick up here. Then from there, our goal will be to get it testable, get it drivable. Once it's drivable and we've confirmed everything, maybe we have to make some adjustments, maybe not. Once all that is done, there's still quite a bit of work. I want to do a fiberglass seat on this bike. I want to do a front and back fender. And one of the really cool things I think about the back fender when I do it, it's going to be sitting on the A-arm. And if you think about the action of the back end of the bike, that fender will increase and move backwards at a slower rate than that seat bar will move up and slightly forwards. So I'm hoping that the back end with the fender and that seat bar, it almost looks like it has a double action. And I think that would be super cool and make the bike look overly cool. Other things, as I mentioned, the tank, be building a tank for it. I'm gonna be doing some sheet metal that wraps up around the side and up over the back where the seat ends, and then down the other side. Maybe an air cleaner catch. I might add a second battery to it. As I get it running and testable, I want to see how long the battery lasts with that air compressor. And I may end up adding another battery to the front or somewhere on the bike. Well, that's about it for this walkthrough. I appreciate your time. I hope you found this helpful. If you have any questions, like mentioned, leave me a comment or send me a message at heritagerestoworks@gmail.com. I hope you're able to take some of these ideas and implement them in your build. Look out for more content to come, and please click that like, subscribe, and share button for me. Help me get other people engaged and out in their shops.